Airplanes fly around the globe. Well, when you're flying in a circle, you're accelerating. I'm going to say it again. You're flying in a circle, you're accelerating. A plane is flying on the equator, traveling at 575 miles an hour. It's traveling east on the equator, and the equator, the Earth itself, is spinning at 1,037 miles an hour. So basically, the plane's total speed, traveling in a circle, is 1,600 miles an hour. You take the radius of the Earth and you add 6 miles for the plane height, and you get 3965 radius. Now listen to this. Can you summarize everything we just said?
We calculated the centripetal acceleration for an object moving at 1,600 miles per hour on a 3,965 mile radius. Key values: 645.65 miles per hour squared, 15.98 inches per mile squared. Curvature: 3.16 inches per second squared, 0.0082 grams. Total G-force. Detection: a human cannot feel this force, and a smartphone would struggle with the noise, but an airplane's inertial navigation system is sensitive enough to detect it easily. These aviation sensors use filters and shock mounts to isolate this tiny signal from engine vibrations.
So we got 0.0082 Gs, which is easily detectable by the aircraft instrument. And here's where she applies it to the aircraft. Can you summarize everything we just talked about?
Traveling at 1,600 miles per hour on a 3,965 mile radius, Earth's radius at the equator, creates a centripetal acceleration of 645.65 miles per hour squared, which is 3.16 inches per square second. This equals 0.0082 grams of upward acceleration. On a flight from Africa to Singapore, flying east, an airplane's accelerometer would detect this as a slight reduction in weight, showing a total G-force of approximately 0.9918 grams instead of the standard 1.000 grams.
So when traveling east, the aircraft's instruments should be showing some negative Gs. Here's some questions I asked earlier. If you're traveling in a commercial airplane at any speed, in any direction, going level flight, constant speed, will your attitude indicator or your accelerometer read 1 gram?
In straight and level flight at a constant velocity, your instruments will read 1 G. An accelerometer measures proper acceleration, the physical stress of weight, not
So the answer is yes.
Yes, because the wings produce lift exactly equal to the aircraft's weight to maintain level flight. Since there is no vertical acceleration, the accelerometer and attitude indicator respond as if the plane were resting on the ground.
If you're flying from Uganda Airport to Singapore on a commercial airliner at a constant speed of 575 miles an hour, level flight, would you feel it in the attitude indicator or the accelerometer?
On a commercial airliner at a constant 575 miles per hour in level flight, you would not feel it in either instrument. Attitude indicator. This stays centered because the aircraft's pitch and roll relative to the horizon are constant. Accelerometer. This reads 1 gram, Earth's gravity. Since the velocity is constant and there is no change in direction or altitude, there is no additional acceleration to measure.
Can you tell me how sensitive a commercial airliner accelerometer is? And if it's sensitive, why is it so sensitive?
Commercial airliner accelerometers are remarkably sensitive, typically featuring a resolution of 10 micro-G, 10 mu-G, or better. For perspective, this is roughly 0.0001 meters per second squared, allowing the sensor to detect a change in velocity as slight as a fraction of a millimeter per second. Why they are so sensitive? The primary reason for this extreme sensitivity is inertial navigation, or dead reckoning. Self-reliance. Unlike GPS, which relies on external satellites, an inertial reference system, IRS, calculates position entirely on board by measuring every tiny movement from a known starting point. Error compounding. To find position, the system must double integrate acceleration, A to V to P. Even a microscopic error in acceleration measurement grows over time. A tiny bias offset of just...
So basically it's super sensitive.
Exactly.
So according to the data that we just learned, if a plane is flying straight and level at a constant speed, going east, it should show negative G's on the instrument panel if you're flying around the globe. But obviously, I think that's not happening. Another clue that we don't live on a ball. Straight and level flight is straight and level flight. Any of you commercial pilots would like to comment on this? Are you showing any negative G's when you're traveling east?